let's try to solve another Leetcode problem 3489, zero array transformation 4. So for this example, we are giving an array nums and we are giving queries. So the meaning of the query is for each of the query from range I to j, 0 to 2. We can decrease a value by 1. So for example, we have 2, 0, 2. So this is for the nums array. So for the first query from 0 to 2, we can choose some indices. So for example, we're going to choose index 0 and 2. 2 it's going to minus 1 and minus 1. So the result is going to be 1, 0, and 1. And then we're going to continue to choose the second query because this must be in order. So for 0 to 2, we're going to minus 1. So we're going to choose index 0 and 2. So this is going to be a minus 1, this is going to be a minus 1, so it's going to become 0, 0, and 0. So how many steps? It's going to be 2 steps, so we're going to return 2. But exactly how can we solve the problem? Yeah, if you check the operation carefully, so this is exactly like a 0-1 knapsack problem. Why? So for example, for the first query, 0 to 2, it's gonna be a minus 1, and minus 1. Yeah, so let's just imagine we're gonna choose all of them. So we're gonna set all of them to be a minus 1, and minus 1. And then we have the decision to choose it or not choose it. So for example, for the first query, if we choose this minus 1, it is okay. So the result gonna be 1. That is not enough, it is not 0. So this means it is not possible. Yeah, so if it is not possible, we're going to continue to use the next query. So it's going to be a minus 1, and minus 1. Now we're going to check the numbers independently because this problem for this number 2, it is not related to this number 0. So currently we just consider all those negative 1 here and negative 1 here. For this 0, we only consider this one and this one. So they are independent for this 2 and 0 for this 2. So first of all, let's just try to check the first number 2. So for this number 2, if we choose a negative 1 and negative 1, so it becomes 0. It is okay. So what about this 0? So for this 0, we will not choose it, and we will not choose this negative 1 either. So it's going to become a 0. Yeah, because we will not choose it. And similarly for the last number 2, if we choose this negative 1, this negative 1, so it's going to become 0. So it is possible. Yeah. So for each of the number, we're going to check them independently. So for this 2, how many queries we used? We used the last query. It's going to be index 1. So it means it's going to be 2 queries. Yeah, so it means the last query is going to be 2. So we're going to return a 2 last index. And for this one, it doesn't matter. So we will not do anything. And for the last one, it will be the index 1 as well. Yeah, if it is index 1, it means we used the 2 queries. Yeah, basically, we used those 2 queries. We can use it or not use it for the first one, but yeah, but definitely, at least we're gonna use the query of the index 1. At least we need to use it until this one, until use the last query, which is the index 1, and then we solve the problem. Yeah, because each of the solution is independent. So this means for each of the number, we're gonna use a 0-1 knapsack to check which gonna be the last index. So for this one, the last index is 1, and for this number, it doesn't matter. So it is a 0, it is okay. Yeah. And for this one, the last index is 1. Actually, we are using 2 queries, so it's going to be 2. Yeah, so for the second one, it is a 0. It doesn't matter. We will not consider it. Yeah. So this is the basic idea. So for example, for the last number, 113. So it means from here, it has a negative 3. Here is a 0, 0. Because this is from 1 to 1, so this is going to be negative 3. Yeah, but definitely, we don't need it. This is not necessary. We will never use this one. Yeah, so this is why we're gonna return 2 instead of 3. Yeah. Now let's just try to use this 0-1 knapsack idea to solve the problem. So I'm going to prepare 3 variables. So n going to be length of the nums, and m going to be length of the queries, and result going to be negative infinity. So the basic pattern is that we're going to check we're going to enumerate all the numbers, because we're going to check each of the number independently until we find the answer. So the final answer is going to be the maximum of the result with a 0, 1 knapsack function. So inside I'm going to use 0 with x. So finally I'm going to return this result. If result not equal to infinity, else I'm going to return a negative 1. If we didn't find a 1, we're going to return a negative 1. Yeah. Now let's start to finish the 0, 1 knapsack function. So we're going to use a case, and we're going to define a function f. So inside I'm going to use the index k, and the value going to be x. Now the condition is that we're going to check this let me think about it. So the condition is that this k is just index. But we are also needed to prepare an array. So this array going to be, let me first prepare the array. It's going to be v if it is inside L to R. If I is more than and equal to L, less than and equal to R, else it's going to be 0 for L R V inside the arrays. So the idea to prepare this array is coming from here. We need to take out all those values. For example, this value going to be for this first number it is a 2, and we're going to take all the values. It's going to be 1, 1 and 0, 1, 1 and 0. And for this one it is a 1, 1 and 3. This one is 1, 1 and 0. We're going to need such numbers to check for each of the numbers, and then we're going to find the last index. Now we want to check the values of x. So if this value equal to 0, it means it is possible. So we need to return on this index. This index is exactly what we are calculating. But what if this x is less than 0? It means it's not possible. Or if this k equal to the m, it means the queries goes out of the boundary. It means basically it's not possible. So we're going to return positive infinity. Otherwise, we're going to directly use the knapsack, but we're going to choose the minimum of all the possible cases. It's going to be k plus 1 with x and k plus 1. So this one going to be the x minus the value. So the value going to be inside of the array will be a k. I think that's all about it. So the idea is we just need to prepare like a number of 0, 1 knapsack, and to find the minimum index. For each of the numbers we're gonna check one by one until we find the minimum. So for example, this number, and this number, and then we're gonna use the 0, 1 knapsack. Why we can use it? Because each of them are gonna be independently. They are not related to each other. So for example, for this number 2, we find an index 1, so we're going to return a 2. And for this 0, it doesn't matter, because we will not choose anything. It's going to become a 0. So this means even for the first number, if we are not choose it, so it's going to be 0. So it's going to be 0 for this one. And for this number 2, we need this one and this one. So it's going to be index 1, so it's going to return a 2. So this is going to be the largest index we find for the 0, 1 knapsack for this for the maximum function, for the maximum of the result, and the 0, 1 knapsack. Now let me just run it to check if it works. Now as you can see it works. Now let me just submit it. Yeah, as you can see it works, even though it is very slow, because the time complexity is this is 10, the length of the nums, and this is 0, 1 knapsack. So what about the value of k and x? So k is the length of the queries. So what about the so what about the length of the queries? So the length of the queries is 1000, so it means it's going to be 10 times 1000. And what about this value x? So this value x is the numbers. Yeah, so it is another 1000 because the nums I maximum, it is the maximum number of the nums I is 1000. So this is why it is so slow, because the time complexity is 10 to the power of 7. Yeah. But basically we're gonna use this idea to solve the problem. Yeah. I think that's all about it. Thanks for watching. See you next time.